Welcome to our review on electronic structures and the periodic table. So hopefully we remember from our previous video that when we're looking at the periodic table, then the elements are arranged by their atomic number on the modern version. And what we then do is we've split them up into these groups, and all of the elements within any given group actually share similar properties. So what we mean by that is that they're going to all react in a similar way to each other, because all of the elements in any given group have the same number of electrons in their outer shell. The first thing we really need to know when we're looking at the periodic table is where to find the metals and where to find the non-metals. So on the picture I've given you here, any of the bits in the kind of bluey purple colour to the left hand side, those are the metals, and then the greenish colour to the right hand side, those are the non-metals. So make sure you remember metals to the left, non-metals to the right. So the good news is that when you sit any of your chemistry exams, you will be given a copy of the periodic table by AQA. So the copy that you get is the one you can see here. Now, first bit of good information to remember is the bit I've highlighted in yellow there is a key. So you don't have to remember which way round the numbers go, because you get a key printed on the one you get in the exam that tells you which is the relative atomic mass and which is the atomic number. The second thing that's labelled on the copy of the periodic table you get in the exam are the actual group numbers. So if you have a look in that pink bar at the top, you can see that you've actually got numbers 1, 2, 3, 4, 5, 6, 7 and 0, which are the group numbers for those columns. They don't label the periods for you, which means you've got to be careful, because one of the things that is a very common mistake when using the periodic table is that when you're asked what period something's in or to find something in period whatever, then people always forget the first period, which is the one that has hydrogen and helium in, highlighted in blue. Because obviously it's not on that far left hand side, so it's really easy to count lithium's row as the first period. So just go careful, hydrogen and helium are period 1, lithium and across is period 2, and so on. So what we're going to do now is have a look at one of the groups in the periodic table with a little bit more detail. And the first group we're going to look at are the noble gases, which are group 0 on that far right hand side. So helium, neon, argon, krypton, xenon and radon, these are the noble gases. Now, the reason they're called the noble gases is because they're very unreactive. They don't take part in many chemical reactions at all. And the reason that they don't take part in many chemical reactions is because they all have a full outer shell of electrons. So as soon as we've got that full outer shell, they're not going to react with anything else. Now, they're all non-metals because they're all on the far right hand side, and as the name noble gases hopefully suggests to you, they're all gases at room temperature. So that's not a trick, they are genuinely all gases at room temperature. The last phrase we may see associated with the noble gases is this one, monatomic. So mono means one, atomic, atoms. So we have single atoms. They don't join together with others. So when we find them as helium, radon, all of this, they will just be a single atom on their own. And those atoms have these very weak forces of attraction between them, which gives them very low boiling points, hence why at room temperature they're all gases. There are some trends or patterns that you need to know about the noble gases. So as we go down group 0, then what we find is that the attractive forces between the atoms get stronger. And as a result of that, then their boiling point will increase, because if they've got stronger forces between the atoms, it's going to take more energy to break them apart. We also find that their density will increase as well. And there's little graphs at the bottom to show you this. And it also gives you the idea of a kind of question they could ask you on the exam. Because you may notice that on each of those graphs, krypton is missing. So they could give you all of the others within the group and ask you to predict the boiling point or the density for the unknown element. So what you need to do there is work out the differences between them and then work out what that missing bar would be. My only advice is don't just go for, with the boiling points you can see that xenon is minus 108 and argon is minus 186 and just think, oh well, minus 110 somewhere between them. Actually work out the differences between radon and xenon, between argon and neon, and then apply that as closely as you can to your xenon to krypton and krypton to argon, because there will be a narrow-ish range that they will give you on the exam. So if you've just guessed quite sort of broadly, you're most likely to lose the mark on that one, so just go careful. Hopefully at the end of this video we can recognise where those key parts on the periodic table actually are, and we can also recall the name of group 0 as the noble gases and some of the key features and explain why they all react in a similar way.